Hey, welcome back. Today on the bench I have my AKAI GX-270D. Now this one I bought probably about 2 years ago. It's been sitting in the queue pile for a long time, getting passed over, doing other repairs. Now I think its time is due. I bought this for myself because I had a reel-to-reel back in my youth and I really missed having one. But that's illogical because I really don't have a use for it today, but it's nice to have a piece of memorabilia to take me back to my youth. And so I picked this one up. Now the previous owner said, oh yeah, we cleaned the controls and the switches, everything works 100%, and you know, I kind of believe him on that point. But you know, you can't just spray the pots and then it's fixed. That's not how it works. So I did try it out when I bought it and it works fine. It does have issues with the this is an auto reverse deck, right? So it does have issues with the head switching. Like when it does its auto reverse, it switches heads. And I think there's a switch in here. Yeah, there's a switch buried in here that you know, corrosion and mucks up and gets dirty and loses connection, all that kind of stuff. So we're going to have to go through and deal with that. But let's plug it in right now and give it a shot. I think we have everything ready to go. I'll just load some tape up and I'll be right back. Let's try this out first. Turn that off. Okay, that 1 watt is not consumed by this. So let's turn this on. You can hear some humming noises. And it's consuming about 16.5, sitting idle. Jumps up to 55. Looks like everything's working. So let me load a tape and we'll see how it sounds. Okay, tape's loaded. There we go. Okay, let's turn up the speed. Okay, it's sounding good. Getting equal out of both channels. Let's try. Fast forward. Tape counter's running. Everything sounds good. So it's pretty much a good runner right now as it is. Now I do want to do some work to this. I want to replace all the electrolytics. I don't believe they've been changed. And I want to replace all the bad transistors. These things are commonly known for having the 2SC 485s or 458s. Yeah, 2SC 458s. And they are a known bad transistor. And this thing's loaded with them. So I'm just going to go through, do a service, and do a upgrade on those parts. And then we'll see how it sounds after that. Okay, here we're in auto reverse. We only got one channel working. It's very, very weak. Both channels there. Let's try reverse again. So it is working, but we have one channel in reverse. I'll reverse. Yeah, it's not coming back. Okay, take the tape off. I want to do some measurements of the background noise. Okay, so I got it stuck in play mode with no tape. So the heads are engaged, the amplifiers are on, everything's working as a normal tape deck, but there is no tape going past the head. So here's our noise figure. I'm on the -50 dB scale. Now, if I'm correct on this, should be -56 or 57 dB. I don't know why it's jumping up and down like that. It's really twitchy. Yeah, and I forgot to mention that was the left channel. Okay, let's test the right channel. On our -50 dB scale, we're at -52. So a little bit more on this channel. A little higher, quite a bit higher. And it seems to be, yeah, about the same, maybe less twitchy, I'm not sure. All you need is a 3mm hex driver. I buy these on AliExpress. They're cheap. They're like $2 a piece. You can buy them in all different sizes. 1.5, 2mm, 3mm. So 3mm works great to remove these cap screws. And then once we get these 6 cap screws out, we should be able to remove, after removing the knobs and the capstan roller, bench roller, all this should come out. We hung up on this. I forgot to take this off. Okay. So let me tilt this back. There we go. Something came out. Plastic push nut. And that came off of here. So we can re-glue that. The rest of them are fine. Alright, put this aside so it doesn't get damaged. So once you got the front panel off, it exposes all the mechanicals and a lot of electronics. Now this area here, right here, and it goes down here, this is all the electronics drawer. Now you can take these screws out on both sides and disconnect some of these connectors, and this should all come out as a unit for servicing, right? You can take this whole thing out. Now you might run into some troubles with some of these switches because they're kind of interlocked. I think you might have to remove. No, actually this should just pull right out. That's our power switch, we don't have to touch that. And then the rest of it should just come out. So let me try this. Let me remove some screws and we'll see how this goes. So I removed 6 screws from the sides. Let's just disconnect this. And let's disconnect this. Let's disconnect this. Okay, so we should be free. Tilt this back a bit. We should be able to just pull this out. There we go. Completely separate and ready for service. It's kind of nice that AKAI does this for these tape decks because they're quite beasts, and you need to break them down to work on them. If I want to do re-lubrication, I got all access now. I can go flip this upside down. I can do whatever I want. We still have boards here, and I think we have the servo board here. This is a servo board, I believe, for the Capstan motor. So we still have to service these in place, but for the most part, I can just take this out of here and get it out of my way now. So here's the electronics block. And you can see all those black capacitors in there. A lot of those will be bad. And we have a removable bottom, so we can take that off. Get full access to the underside. Provides shielding for the circuits, lower noise. But we don't need that right now. And here's the underside of the board. Very easy access. Good to work on. Looks really good. Okay, I'm going to get started on, oh, we got deteriorated foam here. This stuff's crumbling and disintegrating. I might have to get new stuff. Meters. Usually they flop around, but I think they're glued down this time. Yeah, I'm looking at these transistors too, and these ones look like these are the upgraded versions of the 2SC 458s. They don't have the black legs. So these might be okay. I might have to pull a few out and check them, see if they're bad or not. Just working my way through these caps, and this is what I have to do. There's a lot of interstage capacitors, coupling capacitors. So these are all going to get audio grade, the green ones, and the red ones are power supply. So for power supply, I'm going to use solid polymer because they're very low ESR, and they will work great in the power supply for the positions of power supply. For the positions of coupling caps, audio coupling, I'm going to use audio grade. So this is what I take the schematic and I figure out what cap resides where and what purpose it serves, and then I color it, and then I move on to the other diagram here and just identify which cap is which. So because this board has no markings on it whatsoever, you can see there's no markings. You have to pay attention to the polarity, the orientation, so you don't get it mixed up. And I'm also replacing these transistors, the 2SC 485s, or 458s, sorry. I keep getting that backwards. They're coming out, they're testing okay. I have a few that are low in gain, so I'm going to replace them all, and I'm curious to see if there's any improvement in noise level. So let's go through and do caps. And this thing's just gobbling up my stock of audio grade caps. These are what I got left in 10 microfarad 16 volt. And go online, look for them. You can't buy these anymore. They are completely non-existent. I think everybody bought out remaining stock, and it's just a thing of the past. So we need to figure out what we're going to do for electronics like this if we want to have audio grade caps in the audio chain. Now I did go online and find 25 volt caps, 10 microfarad. I'll probably buy up 1,000 or a couple thousand of those just to have an inventory so that I won't ever get in a situation like this again. But yeah, we have to figure out what we're going to do for capacitors that are in the audio chain. These ones sadly aren't being made anymore. Nichicons. Alright, this is all done now. I completed all of the capacitors. I replaced 16 transistors. Actually, when I was testing them, when I pulled them out, they weren't too bad, so wasn't really necessary, but I did it anyway. So this is ready to go back in. It's all been pot's been cleaned, switches, new caps, new transistors, clean the back of the board. Everything is good. So let's put this back together, and then I'll work my magic on the mechanical block of this thing. There's a lot to do there. We're gonna start with the circuitry, the servo, and the power supply, and we'll get all those up, and then we'll have to do all the lubrication and cleaning. So lots to do yet. Alright, so I finished all of the recapping, and that went really well. Not really anything to talk about this board. It works, if you remove this side, you can access these two boards. And if you remove the top, the other side, this side, you can remove this board, which makes it a lot easier. You have to remove the side though, otherwise it's just in the way. These two relays came off the power board, and I checked contact resistance, and it's really bad. 50 ohms on some of the contacts, kilo ohms on the other. One contact I measured kilo ohms. So I'm going to go clean these contacts on these ones. These are 24 volt relays. So that's all I need to finish on this. Clean contacts, put the relays back, and finish assembly. And then we can work on our mechanicals, the motors, relubricating, grease, and all that stuff. Also, these two caps here, these MP capacitors, it's a 0.47, 250 volt. These measure at about 600 nanofarads, both of them, so they're up in value. I think they're some kind of a electrolytic capacitor that's in a can. I don't know. I replaced these with film caps, 0.47 at 630 volts. I got two of them up here. You can't see. Two of them up here, and that replaces these two old things. Other than that, the other caps, this one seems fine. This bulk capacitor up here seems fine. This one down here seems fine. So I'm going to leave them alone. All I got to do right now is clean relays, solder them back in, and then reattach the board, and then I'm finished. Okay, let's go through basic mechanical lubrication of this. It's a pretty simple mechanism. We have two solenoids. We have a head block. We have an impedance roller, supply take-up reel. So this solenoid is your brakes, right? This applies and disengages the brakes on these two reels. So when the brakes are off, the solenoid's pulled in and these turn free. Okay, brakes applied, they have drag resistance. This solenoid here engages play operation, which allows these two posts to rise up and allow the tape to contact the heads. Okay, it also pulls in the pinch roller onto the capstan, and then it's in play mode. And then the motors are set up by electronics, the relays. There's 3 direct drive motors here: capstan, take up, and supply reel. So let's do basic service on this. Let's remove the head block because we're going to need to get underneath it. So let's just remove these 3 screws holding the head block in place. We don't need to disconnect anything or remove anything. We just need to loosen these 3 screws and get them out of the way, and then so we can move the block out of the way. And there's a screw back here that I can't see. Okay. Now our head block is loose. We can just lay it out of the way, and then we expose all our mechanicals. So we're going to have to re-grease all this. Let's start with the brake mechanism first. I'll turn this around and we'll work on the brakes. Okay, what I want to do is I want to lubricate these 3 points. So I remove these clips. I need a bigger screwdriver. I need something with a 1/8 inch blade. Just get in behind here and pry it out. Like that. Okay, put this down here for now. Do not lose these. And keep your hand on it so it doesn't fly across the room. Alright, 3 removed. Let's remove this. Looks like these are all lubricated with oil. It should be a light grease. I'm just going to pull these 3 screws out just to take off the reel and let it freeze up. Okay. Okay. Now we're able to remove the brake. the band. Just put it aside. And this side. Okay. All right. We need to clean these posts. The old grease. Doesn't even look like some of these have grease on them. Yeah, I lost a spring here. This spring goes here. Okay. Alright, I think I'm ready for new lubrication. So let's lubricate this one. And this one. That goes on after. This one goes on first. All right. Connect the spring back. Also, it's a good time to check these switches if you want. Let's see if we have what kind of contact resistance we have. If their switches are really bad, you can replace these. They're common switches. So let's get this attached. See what it says. About 150 milliohms. 100, well, it's not great. 90. 75. Actually, it's not bad. I'm going to leave that switch alone. Alright. Okay, we have this band going around this way. You get some lube in here. And on top. In the hole. Okay. There. All right. Now we can do this one. Around the hole. Alright, now some of our springs came undone. Let's do these springs back up. Okay. Okay. Alright, we can put 3 of these clips back, or 2 of these. Let's put this one on. This one. Okay. That leaves our last one. Lubricate this landing. and put our clip on. There we go. Now there is also a switch under here, and it seems like it's got a viscous damping. But I'm going to leave that alone as well. So we're done with this. Brakes. Let's move on to the play mechanism. Alright, so we got the access. So our impedance roller, the bearing's very good on that one. Let's start removing some of these clips because they all got to come off. There's 8 of them, I think. And these ones have a washer, so we got to make sure we don't mess that up and lose the washer. I just dropped it. Where did it go? Here it is. Okay. This one being difficult. Here we go. I'll clean these off better off camera. You know, the old sticky grease. Okay, those 3 are out. That's loose. Let's remove this one. Probably doing this all backwards, but whatever. Alright, let's dig into this. Let's remove this one. Somebody lubricated this with oil. Don't know if oil is the correct thing to use on these pivot points. Problem with oil is it attracts dust, and then you get, after a while, you get a buildup of dust. Come on. Okay. All right. So that goes in here like this. Okay. Let's remove this. Now this is for the pinch roller. This is the bearing surface, so we got to clean this really well. We'll lubricate this. Okay. Clean the post. Let's remove this one. You're going to see that there's an order in which this is assembled. This has 2 stacked washers. So make sure we make note of that and replace that. And then this here is our okay, that can stay for now. We need to remove this because it is blocking our axis. So let's remove those 2 screws. Okay, just leave it there. Remove this. That gooey grease. Okay. Remove this. This one's going to be tricky. Let's get this one out. There we go. Lots of parts coming out of here. Okay, let's start with this thing. Clean this off, both ends. Clean this post. Oops. My screw fell. I'll get it later. All right. And clean this post. Okay, this one went here. I'll figure it out in a bit. Yeah, this one. No, I don't want to adjust that. What I want to do is get this out. Well, we can clean it here. I want to clean underneath it though. Just going to leave that there and we'll just lubricate it in place. Let's see underneath it. I can. Okay. Just clean this up. Let's disconnect the spring. This is the main part I wanted to get at with the old grease. It's to the point where it's going to start to get sticky and it's going to cause problems. If I look at it this way, this one's bent in. It looks like, doesn't it? I'm going to try bending it a little bit. It's better. Okay. Now I'll get these 3 bushings, these nylon bushings, get these cleaned. Got one. too. It's not very clean. There we go. Had some crap in it. Still has crap. Okay. Three. Clean this one, and then we can put it back together. All right. All right. Inner nylon washers. And we need 3 clips. Okay. See how that feels. It feels good. I'm just going to add a little more. Just going to add a little more. Okay. Better. Now let's do this one. Okay, this one goes on here. Let's clean this. And grease up this post. Grease up this post. And grease up this post. All right. All right, we can put this back on. I'll find you a screw later. Looking good. Okay, I think we need a clip here. We need a clip here. All right. All right, I'm getting close. Okay, so 2 washers goes on there, and we have a large clip. This one's too large. This one. All right, things are looking up here. We have this spring that came off. Don't know what its purpose is. Pulls this thing sideways. I don't know why. Maybe to keep it from being noisy. All right. One clip here. Okay. Okay, we're still missing a screw. All our clips are in. 1, 2, 3, 4, 5, 6, 7, 8, and 9. We got 3 clips left. We got this monster here. Okay. So let's put this together. Clean the post. Yeah. Let's grease the bottom. Grease the top. No, that was the top. This is the bottom. Okay, and our last component is this stretchy thing. Alright, so grease these 2. Perfect. Grease on top. E-clip. There we go. And one more. There. Everything looks good. Got a bit of a slide here, so I'm just going to add a little touch of grease. I think that is it. Alright, that's all there is to it. It's all been re-lubricated. I'm really pleased on how the lubrication is on these bearings. Look at how low friction that spins. I'm wondering if I take this apart, there's an adjustment for backlash. Bearing seems loose. Okay, I still need to do something with this switch. I measured the switch and it is reading very high contact resistance. So I'm probably going to remove this switch and open it up and clean it. I'm not going to do that on camera. It's pretty fiddly. And I'm going to do it right in place here. So wish me luck. So this is what we're getting on this switch. We're getting 15 ohms, 20, 1.3, 0.8. half an ohm. So it's all over the place, right? Okay, I filmed a real nice sequence showing me taking the switch apart and royally screwing it up, so it's not working anymore. But I'll just replace it. These are brand new. And I'll just move the wires over. It's got the same mounting holes, the same plunger location, everything's the same. So I'll install this one. Okay, got a new switch in. It's working great. Now I want to check these heads because on reverse we had a dead channel. On forward we had two good channels. So we might have an open head, or it might be this relay. I'm hoping it's the relay, because if it's a head we have a real problem on our hands. So let's measure the resistance of the heads. And we you have a continuity here, 281 ohms on that head, 279 on that head. Can you see the meter? Yeah, you can. Let's see, we got this one, 276, which is good. Last one, 277. So our heads are good. There's no problem there. We need to investigate why that relay is not switching. This relay is not switching. I'm just assuming it's just dirty. But we can't remove that screw. Well, we'll have to remove these two screws and just remove the head. Let's do that now. That's a bit will allow us. So hopefully we glue these screws in place so that they don't loosen off. There we go. Magnetic screwdrivers, and you have to demagnetize the heads when you're done. Alright. That should give us some wiggle room here. Let's remove the head of the relay board. That screw is loose. Okay. All right. There's our relay. That's our problem, I'm assuming. So let's remove the relay. I'll desolder it. If I can get these wires out of the way. I'll desolder that relay, and then we'll do a service on that relay. So this relay here is the one that does the switching of the heads between forward and reverse and auto reverse. So I'm assuming this is the culprit of the problem. Let me get here, let's get this thing open. Looks like they used the wrong class of relay. It shouldn't be, shouldn't have silver contacts, silver alloy contacts. It should be gold plated. Let's try and see what we got here. Yeah, these contacts are all oxidized and black. And you can see those. Should be gold plated for doing low signal level switching, but it's not. Now this will clean up probably with a very fine grit sandpaper like 2000 or somewhere in that neighborhood. That'll remove all the oxides and it will restore function of this relay. So let me clean this up. You can't really polish them because there's no way to get a polish in there and then clean it after. Okay, what I did is I removed this piece of plastic here. This transfers motion from the armature, that's the armature that's moving, to the contacts, and this is the spring back here that keeps it all in check. And when you remove this spacer, these contacts collapse in on each other and they all connect. So I got two contacts connected together, and I'm going to read the measurement through both of these contacts. Let's just go here and here. We'll bypass the center one, and it's reading 2.3 ohms. Okay, that's not good. This side, it's 12 ohms. So let's clean this up. Now what I'm going to use is 2000 grit. You can buy this on AliExpress, Amazon, go to the auto parts store, whatever. And we're just going to feed this in between the sets of contacts, if it'll let us. Give it a little bit of a sand. Give that one a little bit of a sand. Flip it over. Do the other four sides. That's literally all you need to do. Now if you had a little compressed air, you could blow and get rid of the dust that you just created. But let's check this now. I got 30 milliohms through two sets of contacts, which is normal. This side, this one's 297 milliohms, which is not good yet. So we need to give it a little bit more. Just give it a little bit more. Don't need to go crazy. All you're doing is removing a layer of oxide. Flip it over, give it one more shot. Now if these contacts were plated with gold, you wouldn't do this because the sandpaper would remove the gold and you'd be left with the silver underneath, which would defeat the purpose of having the gold there in the first place. The gold's there to be an anti-corrosion preventative layer. Okay, so we got 38 millivolts or milliohms, which is acceptable. This side, 30 milliohms. So I'm going to put this back in service. I'm going to connect our spring. The center portion here, the center column, goes between the contacts to open them up. So you have to do this. Place that there, and then this clicks on here, and everything is back to normal. Okay, relay's been fixed and reinstalled. Now it's onto the head block assembly. I'm going to go through a few things here. These four posts here are tape guide posts. These ones are adjustable according to height. You tighten or loosen this nut, and it is sealed with some blue paint. So we shouldn't have to touch these, but I am going to rotate them probably about 30 degrees just to give the tape a new surface to ride on that's not worn. So I'm going to turn this one by hand just to give it a little twist, and this one here a little twist, just like that. just to get them onto the tape onto fresh surface. Now these ones you can turn too, but you need to loosen the screw. Use a screwdriver, and there's a screw on the bottom. Just loosen it. They're probably locked in with Loctite or something, and just give them the same slight turn and torque them down again. Here's a screw over here. Give it a slight turn and lock it down. So after 40 years of playing tapes, there's going to be wear on those surfaces, and you just want to turn them a little bit, give it fresh surface to wear on. It's essentially like putting brand new guides in place. Now you just want to clean them, and best for that is the alcohol on the pad. Let's get a makeup pad and just get some alcohol on here and go through and clean these squeaky clean. You can see the dirt on them. I'm mostly concerned about the dirt in the groove here, so we can get down inside and clean that out. Alright, so that's all ready. And clean everything else up too. Dust. There's dust everywhere here. And then I can reinstall the relay. Now let's have a good look at these heads. So here's a look at our glass heads. See that they are definitely glass because they're transparent, and then they have ferrite inserts. Here's the erase heads in the center, and then the other playback head for auto reverse. I don't know which is which, doesn't matter. But you clean these with alcohol and a swab, same as everything else in a tape deck. Get some alcohol going here. If you look at them with a magnifying glass, you can see that there's dirt and stuff on. Just give these a quick clean. Dry them off. This one's the worst. And you can inspect them with a magnifying lens, just if there's any cracks or chips and defects. If there's still dirt or anything else smeared across the heads, you can get a good look if you get in the magnifying lens. I'm just going to go quick and dirty here with a cotton swab, and that should be it for the heads. Now I'm not adjusting anything yet, so nothing's been turned on the adjustment screws. Just going to put it all back together. Just going to put this all back together. The relay gets screwed down on this posts. I don't want to pinch any wires. It looks like that diode's in the way. The diode out of there. Okay. Screw this down. I'll do this off camera, it's kind of fiddly. Okay, now on to servicing all of our bearings for the motors and whatnot. This is the impedance roller. So you need to do the impedance roller before you screw the head block back down, because it will block, the head block blocks one of your attachment screws. So while the head block is out, you can take the impedance roller out and service this. It's just a flywheel on a roller, and that's all it does, is it spins as the tape goes by. Let's clean this. Ooh, slipping. Why is that slipping? Shouldn't be. Okay, so I got about a millimeter clearance here That's what we're going to aim for when we reassemble. So let's remove these 2 set screws, and you're going to need a 1.5 millimeter screwdriver or hex driver, and just go in and loosen these 2 set screws, and then the flywheel should come off. Looks like there's a Teflon washer. Make sure we don't lose that. And then the rest is just disassemble, clean, and re-lube with oil. And that's as simple as it gets. And clean off the bottom of this roller. It's got some kind of brown stuff underneath it. Maybe smoke. I don't know. Let's clean off the shaft with alcohol. This bearing here, I can flush it out. You know what, I'm going to leave it because it was actually in pretty good shape. Let's relubricate this pivot. Remove the C-clip. Let's clean this out and relubricate that pivot. Let's get some cleaner on this stuff. I'm using my favorite cleaner for oil and grease. This stuff removes oil and grease. Excellent. Okay. And then this remove all the old oil and grease. I'm going to apply new grease. All right. C-clip. Okay. On this, I'm just going to use 3-in-1. Okay, and I'll set this so that we have about a millimeter of space. So we got quite a bit here now. I'm just going to pull this out a bit. Maybe too much. Right about here. All right. Very nice. We got our millimeter. Okay. Torque these down. And that's it. Now there's a ball end on the shaft, so you have to dab a grease before you reinstall. So I'll do that right now, and then I can reattach the wire. This is all ready to go. Just give it a touch of grease on the end. And then there's a backlash adjustment there. There is a backlash adjustment for this, and it's this screw here. So when you reinstall this, that sets the backlash for the shaft. So screw that down, and then I'll get adjustment. Now you may be wondering what this wire is for that's connected to this here. This is actually a tape end sensor. It has a post that is split in the center, and it's got an insulator in the center. I don't know if you can see that. And the wire is connected to the top of the post. You can confirm that with an ohm meter on continuity. Let's do that right now. Okay, so we got, so if I go from the wire to the top of the post, we have continuity. If I go to the bottom of the post, it should be open circuit. Okay, so this is actually a switch, and if you have the foil tape on your if you have a foil on your tape, at the end of the tape, when it comes by and the foil touches this, what it does is it sets it up for auto reverse, puts the machine in auto reverse and starts playing the opposite way. So it's an end tape sensor. It's only on this side. The other side is this switch, right, which is connected to this lever. As the tape plays, it should be open like this, and the switch is pressed, and I think the switch should be open. It is, okay, but tape ends, the lever drops and closes the switch. Now this impedance roller and this tape end sensor is, you can test that by when it's playing. You can short the top of the post out to the bottom of the post, and it should go into auto reverse mode. I don't know if a lot of people know about this. On auto reverse decks, you'd have to have, at the end of your tape, you have to put a little piece of foil on your tape as it comes by, it makes contact. That's what that's for. Alright, next we're going to tackle one of these reel motors. We're just going to disassemble, clean, relubricate, put it back together. So in order to get this one apart, we have to remove this fuse block, and it's just 2 screws holding it down to the chassis. Let's see if we can get this out without, the screwdriver won't fit in there. No, it won't. So let's take this off, and then we have access. Yeah, we still have to take it out because it's still in the way. Good enough. Gonna have to have back clearance so we can pull this out. Now, there is a bit of end play on this. It's like a few tenths of a millimeter. It's not that much. 2 set screws. Loosen off the first one. Loosen off the second one. And this should start to move. Yeah. Okay. If you look inside there, there's an E-clip on the shaft. You can see it spinning in there. I'll give you some extra light. See, it's spinning in there. So probably the best thing to do is remove the 3 screws that hold the motor to the chassis, and then we can go in after that E-clip. Motor feels really good with lubrication, so let's just see what we can do here. Okay. Now this is where it gets tricky. You've only got so much wire to move it out, back and out. This is as far as it will go, because the wires go down through the chassis and connect underneath to the capacitors. So this is as far as you can get it. So that's fine. But we need to remove this aluminum cup. There's an aluminum cup here, and it is just a protective cup to keep dust out of the bearing, I'm assuming. So we need to pry it up. I need, or let's see here, I need and there it goes. And it's a very soft aluminum cup. See, I bent it, but I can straighten that out. It's got a felt washer inside. All's good. So let's remove this E-clip now that we have access. Okay, we got an E-clip, and then we have a nylon bushing. This is going to be hard to get out. Here we go. And then our shaft should be free from the stator, the rotor. Pull it right out. We got a problem here because it is catching on something. Do I feel? Maybe this is it. A little piece of shrapnel of steel. Okay. Out it comes. And we got a plastic washer on this side. Another plastic washer inside. So there's a couple there. So what we do now is just clean the shafts, lubricate, and put it back together. So let's do that. Use a cotton swab. It's a cleaner. Not very dirty at all. Okay. That's all we need. Okay, that's all it really needs. There's not much wear on this shaft either. You can see some wear marks. Clean out the dust from the inside of the magnet. Okay, so that we're good on that front. Let's get some 3-in-1 oil. That's about all we need. Okay, sounds good. This back on. This has a shoulder on it. You see that shoulder? It goes up. E-clip. I find putting E-clips on is a lot harder than taking them off. Let's see here. Maybe it's just the camera, their camera shy, maybe that's what it is, I don't know. Click this, there we go. Okay. Sounds good. Let's get our cup. And just squash this little dimple down. Straighten this out. You don't need to do anything to that, just put it back and press it back into place. Okay, that motor can go back. Just gonna put the wires back in the little clip they came out of. Actually, you know what? Let me remove this clip. So I don't have room to work my fingers in here, so I'm just going to remove this clip. This is what I'm talking about, little wire clip. I clip it around the wires first. There's 4 wires, blue, green, yellow, red, and then we just gonna, okay. and then I'll put this clip back in. There we go. There. All right. You can see the clips back. Let's secure our motor. All right, last step is to reinstall our reel table. You have to make room for the belt, tension, the brake, band. Okay. Now this is where it's tricky because there's a lot of latitude and adjustment here. So we need to, this surface needs to be at the correct distance. So let me look it up. Okay, for adjustment of the reel table, this adjustment here, you need, what the procedure is, you load a tape. So here's a empty reel, pretending we have tape on it. And then you set it up into the play mode and the table starts turning. The tape should be loading on the center of the groove. And if it's rubbing on one side or the other side, you need to adjust the reel table so that it centers. The tape is centered in this reel. So what I'm going to do is I'm just going to put it somewhere close to where it needs to be and tighten it down. I'm not going to go crazy tightening it either. And then once the machine's fully assembled, I'll do the initial test and we'll do the initial adjustment, the last adjustment with the reel on the tape. So that's it for relubricating and adjusting the motor. Now, let's give it a test. It's got a nice action, low friction, a lot better than the other side, which is not been relubricated yet. So let's try this side. Yeah, it's not spinning as fast. I'll do the other reel motor and then I'll bring you back in. Yeah, so this motor here is not as good a condition as the other one. It's got lubricant that's going sticky, and I removed a lot of it already. It's kind of residue oil left in here. It's turning green. What I'm going to do is I'm going to give this felt washer a soak in some solvent, and then I'll relubricate it with some 3-in-1. I think we caught this just in time because this was ready to go sticky on us and seize up. So let me finish cleaning this and then I'll relubricate with fresh oil. I'm just blotting out the old lubricant and look at the stuff I'm coming out with. Some kind of green, it's turning into like a green grease. But I did soak this. You can see, I don't know if you can see it, it's not important, not that important. I don't think that we can do anything about it. I gave it a soak and a clean. Just put it back. If you have a good look at this, you'll see that there's a bushing on this side, and there's actually a steel plate here. You can remove this if you want, and then there's a brass bushing. In between these two bushings there's a felt washer in there, or felt piece of felt that's designed to hold oil, I'm assuming. So to get at it, you need to remove these 3 screws, remove the bushings, or the bearing assembly, or the housing from the stator, and then you could disassemble it and clean it. I'm not going to get into that because it's really unnecessary. So we got this back together. Let's give this some oil. How much do we give? Let's give it that much. Okay, I'll reassemble this and then put it all back together. Alright, so the last thing I want to do is I want to service the capstan motor. It's pretty simple. We have 4 mounting bolts, mounting screws here. If you want to remove the motor, these 4 screws need to come out, which means you need to remove some things that are in the way. This lever here is in the way. It's covering a screw, so you need to take that all apart to take it out. But we're just going to go in the back door, remove this strut, and you'll notice that there are shim washers on both posts, and you have to pay attention to what they are and don't lose them, because then you're trying to figure out how to align your motor again or adjust it. So let's, ooh, that is a tight screw, man. Okay, let's get a better screwdriver. Here she goes. I just didn't want to strip the Phillips on that, so let's do this one. Unbelievable. I think they're locking these screws in with some kind of adhesive. Okay. Yeah, see, already my washer fell out. So this is what it looks like. It's like a little copper U-shaped washer. Put that aside. Take this one out as well. This one has 2. So it's shimmed to a specific. Now I hope I didn't lose any other ones. I'll have to check. Because this one, okay. That sets the backlash of the shaft, and it needs to be set to specification. I think it's like, don't quote me on this, but I think it's like 0.1 millimeters or something like that. So let's remove the strut. And then there is the, it's like a nylon bushing on the end. It's actually a bearing, and it's got some dried up grease on it. So I'll remove that grease. And there is a ball bearing at the end of the shaft. You have to remember, don't lose this. It's got grease on it. Now our shaft should be free. We should be able to just push it out. And I hope, I don't think we need to take anything else apart, except it getting hooked on this stuff. Just out of the way. All right. It's banging on this plate, and I just reinstalled this plate, so now I gotta disconnect it. What a pain. I wish I would have done that before I put that plate back on. I'm just going to finagle this out of the way, just so we can get this out. There we go. Here's our rotor. It's got a magnet on the inside. It has nylon washer here, which is staying down. It's got 2 bearing surfaces, one here and one here. And then the capstan. It's all machined to tight tolerances. And then here we have access to the bushings. This brass cap I would not remove. You can remove it, but there's really no point unless you're removing the bearings themselves. So just leave that alone. We'll clean it, and we'll clean this, re-lubricate it, put it back together. It's pretty simple. Not much else to say about this. The main thing I wanted to stress is don't lose that ball bearing out of here, and don't lose the shims that shim up the clearance. It has this tooth thing going around here. There's actually 2 toothed rings, and in between those 2 toothed rings is a coil of wire. So this is acting like a pickup coil, And if you count up each of these teeth, are going all the way around the circumference 360 degrees, if you count up all these teeth and multiply it by the number of rotations per minute, you'll come up with a frequency that this little frequency generator will create. And inside, you'll see there's also the teeth inside, the same number of teeth. So as these teeth pass each other, they create a little magnetic pulse, which is picked up by the coil, which generates electric field, which is fed into the servo. And that's how it knows how fast the motor is spinning. So what I'm going to do is we're going to lubricate this. We got the inside shaft clean. Let's clean the outside shaft. Let's clean this shaft. And it is kind of dirty. Let's see here on my bit of residue. 3-in-1 oil on this bearing surface. Just like half a drop. Half a drop on this bearing surface. Oops, that's too much. And then just slide it in. I have to move my thing out of the way again. There we go. It's good to go. So I'll reassemble the back end of this, and then we're ready to do testing. Alright, I'm just about done here. I did the last few things. I reattached the head block and screwed it down. I installed the pinch roller, okay, and then I installed the auto stop arm because we're going to set this up. I'm going to install the electronics block and get this all put together, and then we'll stand it up and do our alignment of the reel table height, and then we can start working on adjusting the heads. Okay, there's a little bit of a problem here. I'm going to fix this lever is your auto shut off. When the tape comes through and is disconnected from your supply reel, this arm's supposed to drop, and it doesn't drop. See how it's supposed to drop like that. But problem is, this switch I put in here has a stiffer spring inside, and it's pushing hard against that cam, and it's preventing the cam from fully functioning. So what I'm going to do, this spring here is a little too weak. I'm just going to replace that spring with something a little stronger. Should remove this. The spring should actually pull it down, and it's not strong enough to pull it down. And there's no range for adjustment here. If there was a range for adjustment, I would just cut, use the adjustment. Another thing I could do is I could cut the spring. I could cut off probably 2 or 3 turns. But what I'm going to do is I have springs here. I have these springs, and this one here is quite a bit stiffer. This one's pretty soft. This one has quite a bit more tension. This one has a whole lot more tension. That's too strong, I think. So let's try this spring. And we'll put this one in. I'll see how it goes. Okay, new spring is in. It might be a little too tight, to tell you the truth, because this is going to be pushing on the tape against tape tension. And if the spring's too strong, the tape tension won't. There might be times when the tape slackens in this area, and this lever drops out, and then the machine stops. So I might have to adjust this. I might have to use the old spring and cut out maybe 2 turns just to increase it a bit. But this one might be too strong. I could actually stretch that spring out and weaken it. It seems to be a little aggressive on the spring tension, but we're going to try it and see how it goes. Okay, before I load tape, I'm going to test all the functions before I commit to loading a tape. So let's just plug it in and do our first power up. All right. So these should be all dead. Click this up, play, stop, play reverse. Seems to work. Fast forward, stop, rewind. Everything looks normal. Okay. Before I do get too far ahead of myself, I want to be able to adjust the voltage regulator. There's a 24 volt regulator, VR1 here. You can't see it, it's up top. Access from the side. Actually, this is the left side. And there's a adjustment pot on the side of the power supply board. My screwdriver is stuck in it right now. So you measure somewhere here where there's 24 volts. Got to be careful, there's lots of voltages. And right now I'm at 24.14. Let's see if we can tweak this a bit to get it at 24. Pretty close. I'll leave it at that. And then we can continue on with everything else. Yeah, let's try this out.
Upon invitation of the Baptist World Alliance. At that time, we asked for the privilege of meeting with them, and on their last tour, they did us the courtesy of visiting several of our communities to report and to have conversation with our brethren.
Okay, it's working normally. Let's see here. Let's simulate end of tape. Okay, that's working good. Now I don't know if you can see this, but the tape is not loading properly on this reel. It is actually loading towards the front. So what I'm going to do is I'm going to loosen the set screws, and I'm going to move this reel probably about 1 millimeter out, and that should clear up that problem. Let's see if I can sneak in here with a screwdriver. And I should be able to pull this out. Ooh, too much. Too much. Now let's try right there. And then we'll do a test again. Tighten these two up. Let's rewind this a bit. Alright, start play again. If you can see that. I think it looks a little better. Yeah, that is exactly where I want it to be.
At that time, we asked for the privilege of meeting with them, and in the last...
Okay, I'll do the same setup on the other table. I'll flip the tape around, and then that way I don't have to rewind it all the way through.
I think he had said more than 2 words.
This side looks like it's already set up good enough. I'm going to leave this one alone because the tape's loading in the center of the reel, and it looks just great.
Build my church.
Okay, we got a few adjustments to make. I'm just going to go through them quickly. I don't know if I'm going to do them all or not. A lot of the machine's already set up for us when we opened it up, but this is a brake and adjustment. See these 2 levers? They're both down like this, and when the solenoid kicks in, these should be 180 degrees from each other, so it should be a straight line. And if I go like that, you can see it's not quite there. It's got to go a little bit more. I got a bit of an angle here, a bit of a dip. To adjust that, you loosen the screws on the solenoid and you pull the solenoid back a bit, like maybe 1 millimeter. Let's do that. and then we'll just reposition the solenoid to take up that little bit of, oops, a little bit too much. Close it up here. And let's see. It's better. It's better. I'm going to give it a little touch more. Not too much. Let's see here. That's too much. Let's try that. Now, you can see it's flat. I don't know if you can see that. That's a lot better. Actually, I might even have it a little too far. But that's the idea behind that adjustment. So I'll back it off a bit, just a touch. Right there. Yeah, that's good. I'm going to tighten these down. Alright, so this is just to test and adjust the tension of the pinch roller on the capstan. So I just got some scrap wire, made a loop, so I can wrap it around the pinch roller shaft, and then I got something to tie my scale to. You can buy these scales on AliExpress for like $5, shipped to your door, and they're fairly accurate enough for what we need. So we just need to push this on here, and let's zero it. Okay. But first we need to engage this solenoid by hand, and then we pull on this until, well, you can't see. Pull on this. Engage that. Okay, we're at 0. Pull on it until we pull the pinch roller away from the capstan, which is probably right there, and we're at 1.345 kilograms. Now it should be 1.5 kilograms, so this is low. It's a little bit low. So what we need to do is we need to loosen the screws for this solenoid and move it back a little bit, just so that we get more spring tension here. So let's do that. Loosen this set screw and loosen this one. This set screws are tight. And just nudge it back a bit. Don't have to go far. We'll see how this adjustment holds up. Okay, repeat our test. Tear our scale. Pull this in. We're still hooked up? No, we're not. Okay, here we go. 0. Let's start pulling. And we got it too high. Let's try that again. 0. The stupid scale has a lock on the. Yeah, we're at 1.7. I got to go back a little bit on the adjustment. So let's loosen this off a bit. All right. Stupid hook is not very cooperative. Okay, we're 0. Let's pull this in. 0. Okay. Let's pull on it. We still got 1.7. Okay. I'll keep adjusting this till I get it right. So I got it fairly close to the 1.5 kilograms. I'm happy with that. Now the thing is, the farther you pull it away, the increase in force you're going to have here. So you just want to pull it just so it's coming off of the shaft here, and that should work. It seems like might not be enough. I'll keep playing with this. I'm going to try it one more time. It doesn't seem like it's clicking in. There's some slack in this pin. So maybe I didn't have it. Maybe I was doing this. Okay, I'm going to keep going with this. Alright, for this next portion we're going to do the brake adjustment. So we need to put enough tape on this reel so that we have 60 millimeters across. And I'm at 58 or so, 57. So I'm just going to wind some tape on here. Just to build up a little bit of diameter. That's all I want. So let's see what we got now. It's hard to... Yeah, I'm there, I think. Let's try this. $60 millimeters. Okay, good enough. This is an old tape I don't care about, so it's going to get cut. Just so I can put away. This here, I'm going to tie a loop in the end. Okay, with our scale attached, we see how much tension it takes. Should be 350 grams, and we're not, we're at 210. $205. $205, $210. Okay, so we need to increase the tension on this brake. And to do that, we need to adjust this spring. Spring goes up, but we're at the end of our adjustment right now. So we can't adjust anymore. I'll adjust it to maximum, and then we'll see where our spring, our tension is at. What I could do is move it over to this other hole, and it would pull harder. Let's do that next. Okay, let's do our test again. Okay, we're zeroed. Start lifting. Well, it went up to about 250 or so. Let's try that again. It's hard to get a steady reading on this meter. 245 maybe. Okay, let's try plan B. They want 350 grams. So let's move this spring to the hole closest to the band. And that'll pull harder on the band. Okay. Let's try that. Okay, here we go. Well, we're at 305. $320, $305. We're supposed to be at 350. We're not there yet. 315. We're over 300. Okay. Pretty much we're maxed out on our spring. We're maxed out on our holes. Next step it would be replace the spring or shorten the spring. Now I think I'm going to shorten this spring let's take it off and shorten it. That way we can get back in adjustment range. Okay, so you got lots of adjustment options. You got 3 holes here. 1, 2, 3. The closer you are to the band, the harder it's going to pull. When you pull back here, it's going to pull less, more, and more yet, right? Now we have 2 holes here. One's close, one's farther away. Plus we have the slotted screws. We can adjust this whole bracket up and down. Okay, I think I nailed it. So what do we have here? Can you see? No. Let's turn this up. Is that light drowning out everything? Maybe that's better, I don't know. Let's zero this. Okay, starting to pull. About 350, 340. That's good. Let's see what we have for initial tension. It's probably under 200 again. Okay, here we go. 200. Why did it zero? Okay, zero that again. 215 or so. Okay, these brakes need to be adjusted within 50 grams of each other. So this one's right, this one's not. I'm going to go through and do the steps to adjust this brake, and then I'll bring you back in. Okay, this one I adjusted by shortening the brake band, and you just loosen these 2 screws, move it that way, which in turn pulls harder on the spring. Now I could have done the same thing on this, I just didn't realize it at the time. I thought this would screw up this adjustment, but it doesn't. So last thing, these are both adjusted now and they're within 50 grams. The last thing is release the brakes and make sure that there's no dragging, so they should be good. Okay, next up is this tension arm switch. Now this is an auto stop switch, and since I replaced this switch, it needs to be adjusted, and there is an adjustment for it. So the spec is we're supposed to have the switch click within 3 millimeters of movement. So if I move this up 3 millimeters, you should get a click, but we're not. Actually, we're not getting it for quite a while. So let's measure it. Right from here. Okay, so we got about 6 millimeters. You see that? So we got to adjust this. Just loosen this screw, and we'll loosen this screw. And we just need to push this in a little bit. It's not moving. Okay. That's as far as it goes. Here, 3 millimeters. Okay, now the next is this arm. Is it straight up and down, or has it been pushed on and bent? You examine it. If it's perfectly straight, you're good. Now there is an adjustment for this to tilt it in or out, and you actually would loosen the screw and add some shims under the screws. But we're going to check to see if this is correct. If I got it turned on. Oh, pause is on. Okay. We watch this. We flex it in and out, and we watch the tape, how it rides. And it looks like it's centered pretty good in that groove. I don't know if you can see that. So I push it in. I got a bit of movement before the tape moves. See that? Pull on it a little. Same thing. So I think it's pretty centered. I think it's okay. I think I'm just going to leave that alone. So the first step in head alignment is just load a tape. This is a garbage tape I don't care about. If I damage it, scratch it, who cares? It's an old BASF, probably from the 50s, and it's going to leave oxides everywhere when I use it. So this is not a good tape to use for recording, but it is good for doing head alignments and stuff like that. So basically what we're going to be doing first is we're going to be setting, oh, let me get rid of this, sorry, LED lights. First we're going to be doing is we're going to be setting this 0 point here on the bottom of the head, bottom of the tape with the head, and set this 0 point on the top of the head on this one. And then we're going to set 0 point on this head here, and they want 0.1 millimeter on this head. And the way to do that is just get the tape loaded, and I'll show you. Okay, I hope you got a camera in position here so you can see everything. Let's start the tape, and let's just examine where the tape lands on these heads. Okay, so we have a light here, and this one we're looking at the bottom. Let me get over here. Let's see, good lighting for this. I just want to lift up on the tape with the stick. And I just want to see where the bottom and it's pretty much there. Actually, it's a little bit too high. This head is a little too high. I can see, I don't know if you can see it too, when I lift up the tape, you can see the edge of the head for that track. And it seems to be right there. Well, it's very close. Let's look at this one. This one's on the top. I don't know if we can see this. I'm going to pull this tape down. This one looks way out. Is that? Yeah, this one's supposed to be on the top. So let's see here. No, actually it is right on, bang on the money. I don't know if you can see it, but I'm seeing it as I lift the tape down. It yeah, exposes the head. Geez, this tape is really dirty. Scrape away some of that garbage. Yeah, that one's good. This one's good, so we don't need to adjust that. This head here, I can see a very slight sliver of the top of the head. This one here is supposed to be on top, and it's not quite. But this is an erase head, so it is actually aligned pretty good. I'm not going to adjust the height of these heads because they seem to be pretty close to factory adjustments and spec. So we essentially just bypassed these first three steps because we just went and confirmed our tape is. Oh, stop that. Our tape is right where we want it to be, and we don't have to do any adjustments. So we're going to move on to step 4, which is forward playback head azimuth alignment. And we need to adjust point F for maximum output both channels. For this, I'm going to load a alignment tape. Let's see here. Where's point F? F is this one right here. So that would be this screw, and we're aligning the azimuth of this head. So which essentially what you're doing is turning this screw. You're going to tilt this head sideways like this or like this. And we want it perfectly perpendicular to the tape. That's what we want. So we're going to load the tape, adjust this screw, for forward, and this screw is for reverse, doing it in reverse. Same thing, same, we want the head to be aligned properly. So let's do that, and what I'm going to do is I'm going to clean the tape path completely, because get rid of this garbage tape. Get this out of here. Completely clean the tape path and demagnetize the heads, and then we'll start our alignment. Alright, demagnetize my screwdriver I'm going to use for the adjustments, and just to make sure, I just want to test it here. Doesn't seem to be attached magnetically. Oh, maybe a little bit still. Maybe I still need to here's my other screwdriver. I typically keep my screwdrivers magnetized so that they attract screws and stuff, right? So there's my magnetized one. Let go. And here's my unmagnetized one. Okay, I got my Ampex test tape. This is a 7.5 inch per second. We're going to go with this, and we're going to see. We're going to do. Let's see here. The 7.5 inch should be a let's read this here. It should be a 700 cycle tone at 10 dB below operating level for reference. And it should have a 15 kilohertz tone at 10 dB below, and then a series of tones of 12, 10, 7.5, 5, 2.5, and 1 kilocycle. 500 cycles, 250, 100, and 50 cycles at 10 dB below, and then a 700 cycles per second tone at operating level for reproduce gain calibration. A lot of mumbo jumbo there, but basically what we want to do is get this tape test through here with these tones, get the levels so that we're equal, get the levels so that we're in phase. I'm going to be monitoring it on the scope, so everything should go well. So I noticed that the paint markings on all the adjustment screws are from the factory and still untouched. So that alone told me that the height adjustments were correct, and I confirmed it with the tape, and it looked pretty correct to me. So I'm assuming the azimuth is not that far out. If it's probably pretty much bang on too. So we can go through and do that as well. So I just finished doing alignment using these two Ampex tapes, and one of these, they're actually the identical tapes, just one's 7.5 inch per second, one's 3.75 per second. Now these tapes are master tapes that have been created by Ampex. These aren't dubs from another tape, these are actual masters, and you go through and you set the tape speed, which I've already done on both tape speeds, the azimuth on the recorded playback head, or the playback head for forward and reverse. I set the playback levels so that they're both equal, and now I can go forward and do the record adjustments, because once the playback levels are adjusted, then you can go do record levels adjustments. So I'll do that next. I'll load up a blank tape that I can use for that, and we'll go through, and I'll go through and do all the record adjustments, and then this thing should be pretty much ready to go. Alright, so here's the noise floor after the work. I got no tape loaded, it's in play mode. I'm measuring the output here, and I'm on the -50 scale, so we are down around -55 or -56. It's jumping between the two, which is an improvement, because I think we were up around -52 before. Let me check the other channel. There's the left channel. Essentially the same thing. Left channel is really twitchy though. I'm wondering what that twitchiness is. Some kind of noise coming in. It could be picking up bench noise, I don't know. I don't hear anything on the... It seems to be cyclic. me see if I stop the motors. I'll stop the other motor. Okay, so I just finished recording the test video and posting it on YouTube so you guys can have a listen, see how you think it sounds. To me, it sounds, the bass is boomy and the highs are a little soft. Now, got to remember it's got all brand new caps. This thing's loaded with caps in the audio chain, and I don't know, it's, from my experience, usually it takes a couple weeks for those caps to kind of get formed and settled into their role as what they're going to do in the circuit. So this might not be sounding its best right at this moment. Continue using it, leave it powered on for a long time. Those caps will kind of settle down, I think. But for the most part, it sounds okay. But like I said, it's a little, bass is boomy. I don't understand why it would do that. And then the highs are a little soft. But it's ready to go, and it's all fixed up. Everything's been adjusted. Everything's been relubricated. Brand new caps. 16 new transistors in the audio amplifiers, and everything's ready to go. So that's it for this one. And I'm going to be listening to this for a while and playing around with it. So have some fun with that. So take care and stay tuned. There's lots of stuff coming up. Thanks for watching.